All right, now that we know something about earthquakes, how they are formed, what's happening to them, and how mountains come up, let's look at the energy behind these forces. And those are what we're going to call as seismic waves. So there are different types of seismic waves that we'll get into, and a few little terminologies that we need to know. So first, know about that 8,000 earthquakes happen around the world each day. They are a very, very common occurrence. Most of them, however, are unnoticed and don't really register much. But these plates are constantly moving, so we should be seeing evidence of their movement constantly, which we do in the form of earthquakes here. A couple key terms that you should know is one is the focus. The focus of the earthquake is where the earthquake actually happens. This is the initial point of it, and where the earthquake gets triggered and starts from. The next point you need to know is the epicenter. The epicenter is actually more valuable to us because we can't actually get down to the focus. It's normally underground and in the lithosphere, below the crust even. So we're going to talk about the epicenter, which is the point directly above the focus on the surface where things actually matter for us. So let's talk about seismic waves. Waves are just vibrations, and they perpetuate energy. That's all they do is carry energy. They do not carry rock with them. They're not moving rock around. They are just vibrating rock. And if you vibrate rock enough, it starts to break, crack, bend, and you get all the other results from earthquakes. But this is just the energy that is traveling. So there is no rock that is moving with these, at least for what we're talking about. Again, it does vibrate them, but we are just moving energy through the crust, through the lithosphere, through water underneath the surface, things like that. So these waves are going to originate at the focus, and they're going to travel through the earth, and for our purposes on the surface, they're going to be strongest at the epicenter, which is directly above the focus. It's the shortest path you can go from the focus to the surface, so that's where they will be the strongest. They do carry energy away from the focus. So earthquake starts on the focus. All that energy from that movement gets carried in seismic waves away from it and through the Earth's interior and then onto the surface and across the surface. And again, energy is going to be greatest at the epicenter. Depending on what kind of medium you are going through, so what type of rock you're going through, you're going to have different results. It's going to determine how much it shakes and how much it's going to break. Loose rock tend to shake and break more. They just have more space to move, so they have more place to put that energy once they receive it. So there are three types of seismic waves that we need to be familiar with: P waves, S waves, and surface waves. P waves, that stands for primary waves. Primary comes first. S waves stand for secondary waves. Secondary comes second. Surface waves are going to be those, could be either P or S waves as long as it is on the surface. So let's start with primary waves first. Primary waves are longitudinal waves that originate from the focus and go out. They cause compressions and expansions. So if you look at our little diagram down here, you do get areas where you get a compression and you get dilations, which are going to be widening of it. So you can see how the lines here, these two lines right here and these two lines right here, are further apart than these lines here, and these lines here. When they're close together, we call them compressions. When they're further apart, they're dilations. And it perpetuates in that rhythm outward. Again, it is a longitudinal wave, very much like a sound wave. You get areas of high compression and areas of low compression. And these move through liquids very easily. Again, you can think of them as sound waves. If you yell underwater, it actually perpetuates it a lot better than if you yell through air or through rock or something. Next are secondary waves. Secondary waves are transverse waves. When I mention wave, you probably think of a transverse wave where you have this up and down movement. You get crests and you get troughs. Those are your secondary waves. They vibrate things side to side, and they're going to shake the ground back and forth. However, these types of waves do not move through liquids very well. So if your earthquake's going to happen in where your epicenter is underwater, you're not going to see much results or effects of your S waves. However, your primary waves, you will still get plenty of results from. Next are surface waves. Surface waves, like I mentioned before, are just when P or S waves reach the surface, then they become surface waves. This will perpetuate the ground movement because all that energy now no longer has a medium to go through, because it's not going to want to go through the air very easily. So you're going to get a lot of movement in those rocks, and this is where your buildings are going to shake and your ground's going to roll up and down.